Okay, so we've got another presentation now, and it's one of our longer ones, and I think it'll be one that will generate a lot of interest. We've got Francis who's going to join us up on stage now, and it's on the subject of AI. Can AI replace programmers? And also, one of the parts of this as well, will ChatGPT affect the work of programmers? So this could be a very interesting topic. There you go, Francis.
Do I need to press some buttons? There we go. Hi, so I've been given an hour. I work as a programmer, so this question's very important and very close to my heart. It's one of those questions, though, we know Betteridge's law of headlines, so we can probably guess where we're going with this. Yes. But well, we need to define some terms first. How do you define AI? No one's going to talk to me. That's fair. I think... oh.
Have you seen the TV program, Person of Interest?
So I think the question was, have I seen the TV program Person of Interest? I haven't. We'll have to talk about this over lunch.
That's got an interesting take on AI from 10 years ago, which actually turns out to be not a million miles away from where we are. It's a fiction, of course, but it's a kind of scary world of something taking over the world and controlling us all, and that's the kind of most extreme view of AI, but it's the one, sadly, it seems to have a lot of people talking about it right now.
Yeah, well, scary, spooky, possible dystopian futures are good storylines, aren't they?
But before you go on, let me tell you, I got ChatGPT, right? This is my ChatGPT story very quickly. I got it to write me an NDA, all right? When I was at BT, and I gave it to BT's lawyers, and they could not find a single thing wrong with it. And then when I told them it was from ChatGPT, they tried again to find stuff that was wrong with it. So it's an interesting conundrum. But no lawyers, hooray!
Or replace them with robots. That's another dystopian sci-fi. I mean, we do see a lot of fear and uncertainty and doubt around this. So I think today I'm probably just going to bring us more questions and just give us space to think about this and think about where we're going, think about some of the positives and negatives. I think if you do look through a history of stories and thought experiments, the first thing that came to mind for me was Frankenstein's monster. So you've got the idea there that if you pass electricity through a brain, it will automatically start thinking. And that's been recast and retold several times over as a kind of horror story. But if you actually go back and reread the original story, she was asking questions there as well, and wondering what the monster himself was thinking and feeling, and how he fitted in with society. We do see some people trying to build robots. There's a guy called Steve Grand who built a robot you can see on the right-hand side called Lucy, trying to work out how vision might interact with some kind of electronic brain and how it would interact with the world. But most of the AI we see going on, or things that are claimed to be AI nowadays, tends to be around software, hence the title of this talk, Can AI Replace Programmers? A lot of that's centred around playing games, actually, which is quite an interesting take on how the history of AI works and how computers work. Of course, ChatGPT doesn't fall into the game-playing side of things, though some of the roots of the technology sit there. Whether it's a scary, dystopian 1984-style future or not, we shall see. So, like I said, we need to define some terms. I've had one punt at AI, which is straight back to a sci-fi story, and I think that's where loads of our ideas come from. A guy called John McCarthy coined the term way back in 1955. I guess he's pulling there on the idea of electricity going through some circuitry or neurons, and then you automatically getting intelligence. And he had written quite a few things about this and ended up talking about science and engineering making intelligent machines, especially intelligent computer programs. The trouble with that is, I was trying to define AI, and all right, I think we can buy the artificial bit. So now we're trying to define intelligence, which is incredibly difficult. If you start saying things like how well someone does an IQ test, I think there are lots of studies that show that that just measures how well you do in an IQ test. So it might not really be a very good definition of what intelligence means. If you've come across the Turing test, and I imagine a lot of you have, Alan Turing invented the idea of his Turing test to avoid defining what intelligence actually means. He said, if you interact or you were to chat with something, and you couldn't tell whether it was a person you were talking to or a machine you were talking to, then he would start regarding that as some kind of AI sidestepping, defining intelligence at all. Whether or not if you have had a go with ChatGPT, I don't know whether you think it's human or not. I think it fibs sometimes, but that's a different matter. There are lots of subsets of AI. So we've talked about maybe robots and hardware, and then another side of it being focused on software specifically. A subset of AI that gets referred to frequently is machine learning. Anyone come across machine learning or used any machine learning tools? A few, kind of a bit. In some senses, it seems like a lot of what people are using nowadays in calling machine learning will be kinds of regression, curve fitting and so on, which traditionally we'd see more as like statistics, to be honest. And that's cool because you can discover things with statistics. Again, this is an old phrase. Most of AI, and I think where we're going at the moment, you need to go back to the 1950s and learn some history because we're still asking the same questions and trying to achieve the same things. Arthur Samuel coined this term machine learning back in '59. He was trying to get computers to learn without being programmed. It's a bit easier to detect whether something seems to have learned or not. If something starts playing a game, and he trained very, very early computers to play drafts, and it completely lost to begin with. But as it built up experience playing more games, it seemed to have figured out what the rules were, or at least what moves led to it winning. And he hadn't explicitly told it how to win, just given some input data on some games. And it tried and got feedback, tried again and got more feedback. And did appear to be learning, which is slightly different to using statistical techniques to spot anomalies or distinguish between cats and dogs in photographs. So, Arthur Samuel believed that teaching computers to play games was very fruitful for developing tactics to solve more general problems. Getting a computer to play a game gives you quite a constrained place with some predefined rules, and you can work out whether it's learning or not, or whether anything interesting is happening. But you've always got the idea of the feedback, has it won or lost, an iteration, try and try again. We'll come back to the feedback and iteration in more detail in a moment. There's more to AI than just this striving for learning or intelligence. Well, that's the way I see it. Computers can help us in all kinds of ways, and that's why we do some of the machine learning and get the computers to do some of the stats for us, because they're quite good at number crunching and they don't get bored. We're on this kind of spectrum, and have been for a very long time, between augmenting things. So maybe the computer doing the number crunching for you, and then you looking at your graphs afterwards and deciding if you've got a DDoS attack going on, or abnormal traffic levels, or, well, it depends on your domain as to what you're looking for. Or completely automating things. So helping out to taking over. I don't think we're ever going to get to a point where computers completely take over everything. I think I can probably prove that. And I think if you think about it, it kind of makes sense. But the augmentation side of things is quite interesting. Whether that counts as AI or not, I don't know. If you look back through the history of computing, some really simple things that we just take on board as read nowadays, for example, a thermostat controlling your heating. When they were first invented, people would talk about the thermostat making decisions about the temperature in a room. Now that sounds like a really strange thing to say nowadays, but it did seem like some strange kind of magic initially, a machine being able to control the temperature in a room. And if you start to understand the electronics of what's going on, it's not magic, it's not thinking, and it's a bit of a push to say it's actually making a decision for you. But now we just be able to set the temperature on a thermostat as quite normal and don't think about that as being AI or the machines taking over. But we've still got some control there. We say what temperature we want, and it helps us out, brings it about. If you look back through the history of not just thermostats, there's all kinds of machines have gradually taken over some of the work people have done. And yet, despite the fact we've got tilling machines for sowing seeds and printing presses and all the rest of it, we aren't all unemployed, are we? I guess you're all here because you've got a job with your company. So despite the fact we've seen some automation over time from a variety of different types of hardware, we've still all got jobs. The nature of the jobs has changed. So maybe AI won't replace programmers, but maybe it'll change the nature of our work. And I think it has been since the very beginning of computers, to be honest. Now, here's another question. Okay, if you say, instead of, as well as the augmentation, if you start automating things, what happens? I think if you look back over just the last 5 or so years, maybe a bit more than that, we've seen some experiments with some earlier chatbots released into the Twitter sphere, for example. Does anyone remember the chatbot Tay? Oh, from quite a while ago. It had been trained in one of the big companies and they let it loose on the world. And as people interacted with it, I guess the feedback mechanism was the number of likes it got and how many people replied. And it basically turned into a bit of a lout, slightly racist, and said some really quite hateful and misogynistic things. Because the feedback meant that got the response, I guess, and they had to pull the plug on it because it started to cause an embarrassment. Interesting experiment, but that was just doing what it had been trained to do, which was get feedback and get likes. If you automate what you do at the moment, you might start seeing some worrying trends going on. I've seen examples of, I think these were academic rather than real life situations, where a computer was trained to decide the sentence length for various prisoners. And you started spotting all kinds of strange things going on. Would it surprise you to learn that longer sentence lengths was suggested for black people than white people? Why do you think that might have happened? If it's in the training data, but that's what's tending to happen at the moment, and you tell the machines, take over from me, do things the way I do them, the machines might then start doing things the way you do them. And we might be in a very important place and time now to start thinking about what we're doing and thinking about the bias in what we're up to. There was another academic paper published where the researchers were trying to look for structural features of someone's face to predict criminality. Does anyone recognise the phrenology head picture at the bottom? There was an idea, I think, back in Victorian times, that by the shape of someone's brows and like how close their eyes together where you could work out whether they're going to commit a crime or not, which has been completely debunked. And yet people are starting to try and do the same thing again. So you need to learn a bit of history. Say, is this particularly sensible? And are we being biased at the moment anyway? There are loads and loads of other examples. For example, where, say, Facebook was labelling pictures of people and saying, would you like to tag your friend? Some of the technology behind that, when it's been presented with pictures of people, it does all right to a point, but it's mostly been trained on white people. It's given pictures of some black people and identified them as gorillas, which is absolutely shocking. But if you don't have the right balance of training data, you're going to get things wrong. And that comes out of statistics. If you've got a very biased, unbalanced data set, all your data is, for example, about males, you might miss some things that happen with females. So if you're going to start doing stats, or anything like stats, you need to have good data sets and be aware of unbalances in them. There's a famous phrase in computing, you send garbage in, you get garbage out. So I think the important thing with AI and machine learning and stats, if you put bias in and you don't do something about that, you'll end up getting bias out. So just keep your eyes open, think about any kind of scripts you're running and things, and think about, I mean, this isn't always about racism or sexism. If you've got data on normal day-to-day operations, you haven't got much data on situations where your servers are under attack. So you need to do something to be able to train your machines better, to spot at very least something anomalous is going on. You need to keep thinking, even if you're trying to get the machines to do all the thinking for you. So maybe I'm not going to get replaced completely by the machines yet. Back to the augmentation side of things. Actually, the computers are cool sometimes. The idea of AI and robots taking over might be scary, but just pause for a moment. Most of you got a laptop in front of you. I relied on my mobile phone to try and get here. Google Maps was not very helpful. I went in the wrong direction 3 times, but then that meant the 4th time I was going the right way, so that panned out in the end. The fact you can draw on a tablet leads to some artwork and some other interesting things. This guy called Kevin Warwick, who was playing around with microchips a long time ago, slightly strange, and in certain circles is called Dr. Cyborg. He got his RFID tag from his door pass implanted in his arm, but he kept forgetting his door pass and reasoned he wouldn't forget his arm. Thing about some academics, so he could just scan his arm on the way through, which sounds like a crazy experiment to do. But as a result of that, my cat's got a microchip. If you've got a pet cat or dog, you might have the microchips so you can find them. Now, that's not AI, but that is using computing hardware and software to augment things and help things out. Whether you take it too far and end up with RoboCop and some other sci-fi stories, well, that's sci-fi. But that computers can be useful and they can be really helpful. They can have fun as well. There's loads of modelling guitars. My husband's really into playing guitar, and he can instantly detune it at the click of a button without having to faff around with all the strings. So that's fun. And actually, can AI replace programmers? If we go back to the 1950s, we'll see most programmers then knew some hardware as well and would have to make their own parts of circuit boards, and I can't do that. And we get higher level languages as well. So if you go back to the 50s and 60s, you might be right down giving machine instructions, which takes a lot of concentrating on. Nowadays, we have even interpreted languages like Python and so on, and JavaScript, as well as some compiled languages like C++, which is one of my favorites. In order for those languages to work, we need some other computer programs that interpret those back closer and closer and closer to the noughts and ones and the electricity that the machines understand. So at the moment, as a programmer, a huge amount of my work relies on computers automatically doing things for me. which might mean I'm partly replaced in terms of what might have happened 70 years ago. But the nature of my job's different. I can think at a higher level and not have to be right down in the noughts and ones. So, automation is a good thing. Sometimes. We can certainly rattle off loads of examples where computers are monitoring stuff for us. Maybe you've got a dashboard up at work so you can keep an eye on something that's going on. That's just chugging data around for you. In no way would you say that's being intelligent. But you can wrap some stats around it and it can make something go red or start flashing if something unusual is happening. Again, that's not intelligence. That's probably the statistics part of the machine learning side of things. But then sometimes we end up with a tendency to go, hooray, I've thought of an idea, so I'm going to do it. It's brilliant. I've got a particular beef with automatic taps. I don't know about you. Get some soap on my hands, try and get some water out of the automatic taps. And it doesn't always work seamlessly. And there have been some studies done that show, again, that it's tended to be trained on white people. And sometimes black people, it doesn't recognise the skin tone at all. So we need to get better at this. Think about what we're automating. Why? Automatic flushing toilets. I can see through COVID, maybe not touching things, but mildly unnerving if you're trying to use them at the time. Self-driving cars, good idea? Yes, no, bad idea? Not sure. At that point, like, what problem are we actually trying to solve? The expense of being controversial, I think maybe a better public transport system might be useful. Or teleporter. Then I wouldn't have had to have used Google Maps to get from the train station to here. I could have just materialised on stage. And teleporters never go wrong, apart from in science fiction. Yeah, okay, maybe I haven't thought that one through properly. As we automate things, all computers are reliant on electricity. A lot of people being very disparaging about the so-called cryptocurrencies and the amount of electricity they're burning through. ChatGPT is a huge language model. It's called LLM, a large language model. They take a huge amount of power to train. Even if you just build quite a small neural network on your laptop, you'll hear the CPU trying to overheat for a bit. It's doing some serious computing. So sometimes you need to ask yourself, why am I doing this? Is it really worth it? Just throwing that out. Now, all right, automation is useful. I've said as a programmer, I will use all kinds of tools. And I use C++, which is a compiled language, so I type it in, and then the computer compiles it down for me to something the machine understands. And if you talk to programmers, lots of them will use things to automatically format the code for them. There are all kinds of models you can build that map your code straight to a database if you're using a database and so on. There are loads and loads of libraries that programmers use. And sometimes they come with the tool chain you get anyway. So the computers are doing loads of our work for us, as I said. Programmers rely on their computers. And they do a lot of work for us already. But I was supposed to be talking about AI, and I think we've registered automation seems to be something that we use computers for a lot, but it's not AI. If you look back to the 60s, there are all kinds of ideas about, in the future, we'll have robots who can be nannies for us and take our kids for a walk, which hasn't come to pass. Wonder why not? Maybe there are more important things we could be doing. But some other things that are automated that I think are quite cool. I've got a Roomba. Anyone got a little robot vacuum cleaner? It's great. It's mesmerizing to watch, but that's not even got a neural network or a neural brain in there. It's following a basic space traveling algorithm. And some of these algorithms date back a long, long time, but it's quite mesmerising to watch how it's working out, trying to go backwards and forwards, and remembering or learning where the bed is in the bedroom, and so on. That's not AI, is it? And yet, like I said about a thermostat, if you saw that initially, you go, wow, it's magic. And then we start getting used to all these things that are automated, that have got clever algorithms. Breaking news, an algorithm is neither clever nor smart. It just is the set of instructions that some humans have created. Unless the computers created the algorithm for us. We'll come to that. And we've talked about if we automate what we already do, we can get in trouble. Well, yet another example of somebody saying it takes ages and ages to sift through all the CVs for these jobs. Let's get the computers to do it for us. And the computer, being clever or intelligent, went, all right, you've employed these people, so that's what employable at this company looks like. Here are CVs. Almost all of your employees are male. These CVs give the impression they're female, so I will reject them. If you automate what you're doing at the moment, just watch out. Maybe deal with the problem you've got first. Or use this as an opportunity to balance things out. So, yeah, maybe we should take ChatGPT and the fact people are talking about AI so much as a time to stop and think about what we're doing and what we actually want. So, all right. I think I've given up on trying to define intelligence. I'm certainly volunteering on that. If we build a brain, will it think? What's the idea behind lots of so-called neural networks? If you're not familiar with the insides of a neural network, it sends in some signals, which in the simplest case might just be noughts or ones, but they could be other numbers, or you can take some words and represent those words numerically, sends them into a node, one of the little circles, and does some multiplying, and then adds them up, adds all the weighted or multiplied up inputs together, and sends them through a function like sine or tangent or something that's a curved shape. And then you get the idea of a neuron firing. If you get a bigger signal, it's like a 1 or a neuron firing in your brain. If you get a smaller signal, it's like it doesn't fire. And they're all wired up together, and all the outputs from one node go into another node. And then they go into another node. And the more nodes you've got across the screen, the larger or deeper the neural network is. So deep learning is just a neural network with loads and loads and loads and loads of nodes doing the multiplying, the adding up, and the activation, and getting numbers out at the end. Is that the same as thinking? Well, your brain has nodes firing, but it's not connected up in the same way, and I don't think we fully understand how human brains really work. Whether a neural network's a simplistic model of a brain or not, I don't think it is, but we can do some interesting things with them. And they can usually manage to spot a cat or a dog in a picture. How useful is that? Well, I don't know. So some of the early computing attempts were to get computers that could play chess, which is quite complicated, but you can teach them the rules, and they can store more state than the human brain can. So eventually they got to a point where a computer could beat a well-seasoned chess player. It was quite a while ago now. Anyone play Go? I quite like playing Go. The rules are much simpler than chess, but the number of possible moves is absolutely mind-blowing. So you tend to end up going with patterns to find things. You're either a black tile or a white tile. You put them on the board, and if you surround your opponent's tiles, you can take them off. So you count the tiles at the end and how much you've surrounded. You have to completely surround them. There can't be gaps. And the number of possible moves, like I said, is just absolutely mind-blowing. So in order to get a computer to play Go, you needed a better algorithm than just the brute force look ahead. If I do this and they do that, then this will happen, or that, then the other will happen, and then work out the best move of the possible moves. So a machine was built a while ago, well, it was software rather than hardware, called AlphaGo, that did learn how to play Go. And this harks back to Arthur Samuel's thing from 1959, right? Where he was doing drafts, which is a much simpler game, but the Go computer just started randomly doing stuff, and you go, that's an illegal move, now you've lost, and started to find some patterns itself. Again, whether that's thinking or intelligence, or just the result of an algorithm, I'll leave for you to decide. Can we define AI better now? We're still going to avoid saying what intelligence really is, but if you look at pretty much any AI or machine learning algorithm, it's the pseudocode for it, the basic instructions say, while we're not done, so done might be we've learned how to win at chess, or we can vacuum the room, and so on, just randomly try some stuff. There's usually something random in an AI algorithm. Maybe it's in conjunction with a heuristic. I might tell the Roomba to go in a straight line until it hits something. Test the random things. So that's where we need the fitness and the feedback. I said at the beginning that the feedback was important. Remember the better things, and then try again. So we're testing stuff. There needs to be some way of giving feedback. And we're just looping round. There might be some randomness in there. Okay, that's AI. Can AI replace people? Already said no to that. I counsel a warning against using the word Luddites for anyone who's not into AI or computing. Again, if you look back at the history of the term, the people there weren't angry at the machines replacing them per se. It was the way in which things were being done. So just need to be careful all the time. Can AI replace programmers? Well, anyone here program? Write a script occasionally or something like that? Or even if you set up a spreadsheet or something, you're still giving instructions to the machine. If you go for a job as a programmer, you'll frequently be asked to code up something relatively simple. And FizzBuzz is one that does the rounds. Some people say FizzBuzz is a children's game. Some people say it's a drinking game. And some computer programmers think it's a little coding exercise. You count 1, 2, and traditionally go up to 100. Some people say you should only go to 99. Opinions vary. If you find a multiple of 3, you say fizz. Multiple of 5, you say buzz. And a multiple of 3 and 5, you say FizzBuzz. Nice and simple. Well, it's simple to convey the idea. Some programmers are getting a bit of a knot, especially if you're under stress. And trying to set up tests for this without writing out all the numbers first yourself by hand is quite difficult. So I cheated. We'll come to that. Can AI code FizzBuzz? If AI can code FizzBuzz, it can do a programming interview and it can take over my job, right? Now, you can get the machine to generate code for FizzBuzz. There's something called genetic programming, which dates back to the 80s. That's based on the idea of genetic algorithms, which are, in some sense, a subset of this AI stuff, or thinking algorithms. Don't know if anyone's heard of them before. I'll give you a little overview. I've written a book, so if you want to play around with some code and build them up yourself, you can. However, time is short. So, a genetic algorithm is driven by a feedback mechanism, which I've used a quote here from a guy called Norbert Wiener, who was involved in some of the early thinking about computers controlling things. And that led towards some of the early developments in AI. So, genetic algorithm. We've said most AI involves something random. So you randomly set up a list of numbers or words, And while you're not done, you try them. Maybe you're putting them through a function, and you want the function to be 0, for example, so you could do that for a root-finding algorithm. Or maybe you're doing some kind of cost-benefit analysis, so you've got two things. You want the cost to be as low as possible and the benefit to be as high as possible. So you test them, and you pick out some of the better ones, and you create a new list of potential inputs by crossover. I've got a picture coming up. I'll show you that in a moment. And maybe you change one of the numbers in the array somewhere a little bit, or all of them a little bit. It's pulling on the idea of Darwinian evolution, right? That over time, the fittest survive, and they do this by mating and then having random mutations once in a while. So if I'd got 5 numbers, noughts or ones, the crossover, I might take part of one and part of another one. So the first 3 parts of the first and the 2 parts of the second. And I've got 2 new things to try out. And they've got bits of the parents, bits of both parents. And then maybe I can flip one of the noughts to a 1 or vice versa. So a genetic algorithm will then spew out some numbers that work for you. You can do that for things like seating plans and apply it to all kinds of different problems. Genetic programming, instead of just having a list of numbers, makes a tree structure. If I want to do 2.2 subtract something in an equation, so you can see on the right, I can represent that as a tree structure. So I've got the plus at the top, which is the plus between the 2 brackets, and then I represent it like that with numbers and at the leaf nodes. And then binary instructions, so in the instruction taking 2 numbers for addition and multiplication and so on. And once I've done that, I can do the same thing as I did with the genetic algorithm. I can take part of one tree and slam it into the other tree, and then I've got a different equation or computer program. So genetic programming looks almost exactly like the genetic algorithm, but instead of just a list of numbers, it's got a tree structure. So now all I need is the feedback for FizzBuzz. I said I cheated, because you're in danger of just writing down what all the outputs are going to be. So if you spend a bit of time thinking, or cheat and get someone else to think for you, you can come out with quite a small set of tests. And then we use those as feedback for our AI. I used an open source Python library. Only a few of you said you program, so probably most code you go, anyway, this is absolutely horrific. Now, if you don't know code, you won't know what to look for, and you won't know what's going on here, but I'm going to move and point and not fall off the stage. If we've got either FizzBuzz or FizzBuzz, then we're going to output FizzBuzz. It's just made loads of extra stuff up that's completely unnecessary, which is all my own fault because I didn't tell it not to write unnecessary code. I just gave it tests to do FizzBuzz, and it does FizzBuzz. It generates the correct outputs for the numbers 1 up to 100, and I think it would actually generate the ones beyond 100 as well. Am I pleased with myself? It took me about 3 days to make this work, and I'm sure I can write FizzBuzz in about 5 minutes, so was it worth it? That's the Hall of Fame top entry. That was the best one it came out with. It did some other things that were even bigger, so what do we mean by best? Was it worth it? Do we want to see the Hall of Fame or indeed any other Hoff anyway? No. The human way, again, if you're not used to code, that doesn't matter. You can see there's considerably less to concentrate and think about. This is an older version of Python, so you need brackets around the S at the bottom. So you can get computers to generate code to do exactly what you want. But the trick there was trying to write tests to describe exactly what we want. So if you're going to replace me or any other programmers, You're going to have to write the tests. You're going to have to say precisely what you want. And that's really difficult. When someone writes some software for you, or even, say, if Microsoft come out with a new version of Office or something like that, there usually are some design flaws and bugs and so on, and then we give them feedback and say, I don't like that. As a programmer, I like to try and talk to my customers as soon as possible, get a small minimum viable product or little prototype working, so get feedback earlier on, just to give the customer a chance to say, I didn't mean that. There's so many fairy stories where someone's granted 3 wishes and something goes horribly wrong. Careful what you wish for. And with AI, or any computer, it's going to mindlessly do exactly what you ask it to, which might not be what you want it to. I mean, if you were to replace me, I was very rude about the AI-generated code just now. Perhaps that doesn't matter if you get rid of all programmers and you're all happy to write the test precisely and keep an eye on what it's up to, then it doesn't matter if it comes out with incomprehensible code. There's no human will ever have to look at it again. So, AI, bit of random, that feedback and iteration crop up. We've seen them in genetic programming just now as a deep dive example, and it happens in anything else. If you want to understand how an AI algorithm's working, ChatGPT or whatever, look for where the feedback's happening in the training process or maybe over afterwards, and what it's looping around, what it's trying to zone in on. And there's going to be some humans involved in this at some point, hopefully during the process rather than right at the end. So talked about AI a bit, had a little bit of a dive into how some algorithms work. And I talked at the beginning about software versus hardware. If we're in a place where these digital computers can write code, and they've been able to do that for quite a long time, and the same algorithms can be used to design circuitry, perhaps we are on the verge of some kind of dystopian sci-fi film here, because theoretically computers could build themselves, mend themselves, program themselves. But they don't, because there's humans in the loop. And that's a good thing. Could you have AI? There's an idea of artificial general intelligence and getting computers to do anything. And it always comes back to 2 schools of thought on whether intelligence needs that physical body or not, and whether our physical body is part of how we learn as well. You're driven by some instincts that, for example, you're hungry or you're tired, and that adds to your learning. So does AI need a physical body? And then there are loads of sci-fi stories, of course, about you, whatever that means, being uploaded into cyberspace after you die so you can live forever. Are you just your thoughts? If you went in a teleporter, I said earlier, they're much better than self-driving cars, right? Nothing goes wrong. If you go in a teleporter, you're destroyed, rematerialized somewhere else with completely different atoms. Would you go in a teleporter? Have you ever thought about it?
I'm in the first, man. And anything that stops me having to get on British Rail, sign me up. Sign me up.
So the quip was, anything that stops me having to go on British Rail, sign me up. And you know, after this morning, I hear you. Well, okay, sci-fi again. Of course, Star Trek gives us the idea of the Borg, and so that isn't a complete machine, that's kind of half person, half machine. I want to just mention Norbert Weiner's thing again about cybernetics. I think there's yet another new programming tool that's been around for a while called Kubernetes, which you use for setting up from infrastructure and stuff. I've never played with it properly. But Weiner introduced the word cybernetics into common use, and that means about steering like the pilot of a boat. So I think that we need to steer things. And there are loads, even the people who've produced ChatGPT are part of the OpenAI movement. And you can read what they're up to, find out what they're up to, give them grief about some things, ask where it's going. And sometimes actually sci-fi does end up feeding lots of ideas in the long run. Sci-fi is a space where people think about what's possible and what might go wrong or what might go right. We've talked about some of the augmentation and model guitars and some cool stuff, so it's not all bad. I've talked about the human in the loop. The phrase was introduced quite early on in AI research to make sure that you didn't just kick the thing off and, like I said, careful what you wish for. Here's my FizzBuzz test, write FizzBuzz for me. You'd stop it every now and again in the iteration and go, hang on, I've changed my mind. I didn't really want everything I touched to turn to gold. That's terribly inconvenient, everything apart from. So it gives you the chance to tweak and be more precise about what you want. Nowadays, when you see the phrase human in the loop, it's been, to my mind, misappropriated. Ever clicked one of these tick boxes? Some of you will have done. It's inevitable. It's looking at all your history of internet browsing, or bits of it, to try and work out whether you're a bot or not. We know that. Sometimes it goes, not sure. I need you to do a task. Don't see these very often as the recapture's getting better, but they have happened, and they still happen occasionally. Why is it asking you to label traffic lights? What happens if you get it wrong? If it thinks you've got it wrong, it thinks, there's that word again, or the statistics show that you haven't picked the same squares most people pick, so you might then be presented with something else. Which means it's building up a body of labelled pictures pointing out where the traffic lights are, which can be used to enhance Google Maps, as training data for self-driving cars. At one point recently, I had one that asked me to identify the steps in a picture. And yes, you might have got the idea, I sometimes watch Star Trek. I've also watched Doctor Who, and I was not sure whether that meant the Daleks were coming for us next or not, but I am certain, and it is a fact, that when you click the boxes here, you're the human in the loop in the sense of you have been co-opted into labelling some training data for AI for free. Lots and lots of AI models need trained data. In order to spot a cat or a dog, they need millions and millions of pictures with labels saying, cats in here, dogs in here. Who labels the data? Anyone heard of the Mechanical Turk before? This is a very, very old idea. It was supposed to be this amazing chess-playing robot. There's actually a big table with a person hiding inside it who was moving the chess pieces around, but it looked like a robot, and everyone was wowed, and it got brought out to dinner parties. And there's several variants of it. I think you can find some in some old museums, and people have written about them. There are loads of pictures on the internet. Why is this relevant? Well, it appears as though a computer's just doing something, but it's actually a person working hard underneath. And some people need the data labelled. whether it's spotting cyber attacks in some PCAP data or some medical data or whatever, you need the data to be labelled for a lot, not all, a lot of AI. And you can buy time from Amazon's Mechanical Turk. And there are people in the background who've been paid peanuts for this. If you need loads and loads of data labelled, other Mechanical Turks are available. There are several workers' cooperatives out there that actually the money goes straight towards the people doing the work rather than through the middleman. So, yeah, okay, the recapture. To what end? Why is that automating things? Well, they want labelled data for Google Maps and maybe self-driving cars. So ask yourself, why is it doing this? It's quite interesting as you find out why things are happening, actually. You go, no, right. So it doesn't matter if I miss some of the traffic lights or bridges, fine. Well, just, okay, steered into some dark and some ethical issues there, just cheerful, thought-provoking stuff before lunch. Well, just hold on to some of the good things and some AI, or maybe it's more augmentation, makes all kinds of things possible. Stephen Hawking was reliant on his computer voice and his wheelchair. And as we're learning more about our bodies and how our minds work, we are creating some wonderful things that help out people in a variety of different ways. So computers can be great. Now, a few minutes left. I talked about being hard to come out of the test for just FizzBuzz. You can use, look, I've showed that we can get AI to generate programs for us. We can also get AI to do some of the testing for us. I strongly recommend you don't rely on the computer to test your network setup or your software completely for you. We need that human in the loop all the time. But you can test the tests themselves. As a programmer, I've done this sometimes. I've got some code, I've got some tests around it. If I then get another program to automatically change some of the code, a less than to a greater than, a 0 to a 1, if my tests still pass, then I've either missed an edge case, or maybe that bit of code was waffle and I could have put it more succinctly. So we've got that random bit again, the computer randomly doing something with my code over and over again with some feedback. Is that AI? Is that intelligence? I don't think so, but I think it's really interesting and really useful. Just saying. Other ways of doing testing, some stuff, particularly if you're doing some statistical mathematics, it's quite hard to come out with precise tests for what you want. But you can look at the patterns of what's going on. You can say this never drops below 0. And the computer thinks, oh yeah, I'll try and make this 0, and tries to flush out some edge cases for you. And then the extension of that are things called Fuzzers. Anyone come across them before? I should look them up, they're quite good fun. Sometimes they get used in penetration testing. And it's doing a similar thing to the AI description I gave you of that iteration, a loop, and the feedback to try and nudge towards something, where the computer will fire some random inputs at your code and see if it crashes or not, for example. And it can watch things like the memory growing and stuff and go, all right, if I push it a bit more this way, it might fall over in a heap. So rather than you randomly battering the keyboard, automate it, get the fuzzers to have a look for you. So yeah, look up fuzzers. There are lots of useful tools out there, and you don't just need, I've seen programmers use them to test their code, but you, like I said, you can use them for penetration testing as well. It's got all the elements of AI. Is it intelligent? No. Is it useful? Yeah. Yes, it is. So, can AI replace programmers? I've already said, yeah, well, I can make the computer program FizzBuzz. That was considerably more effort than me just writing it myself. This falls under the idea of program synthesis, which again has been that hope's been around since the 1950s. Some programming languages like Lisp were deliberately designed so the program could change itself as it ran. The idea, you write the program once and it'll fix itself and get better over time. And this program synthesis is being used in a variety of ways. We'll step back to before ChatGPT. Just hold in mind, if the computer writes the program, well, you could write the test afterwards and see it works. And a lot of the program synthesis I've seen going on recently hasn't involved the testing bit, and I think the testing is really important. Something was introduced a while ago, before ChatGPT hit the scenes, which works a bit like predictive text. So as you're typing in code, it suggests what you're probably going to type next, which may or may not be useful, I don't know. A lot of this was using some deep learning stuff. I've already said deep learning is just lots and lots and lots of layers of neurons in the neural network. It kind of worked like a search engine for coding. I had a go with it. I'm not very good at Java anyway, more code, apologies. It's supposed to be generating fizzbuzz. But even to the untrained amongst you, there's not a single fizz or buzz in there, so I think we can say without even trying that's not going to work. So that didn't work very well. But it's all right, because now they've invented ChatGPT. I didn't record the argument I had with it about fizzbuzz. Now, take some of the words out of your problem and then start off. So if I say, how do I write hello world? It says, or how do I write code for hello world? It says, you write code for hello world. And the next word is based on the last word. It's predicting what words are likely to come next and generating things for us. And sometimes there are examples of it generating legal documents which pass the legal team. And there have been examples of it generating code that works. And it managed to do hello world. I then asked it how it would test this, and it put the little hello world statement in the middle of the test, so I couldn't call the program from anywhere. I've seen other examples where people have asked it to generate code in one language, and it said, sure, you can do this, and pulled some code from a completely different language using a feature the language that was asked for doesn't have. Which might be all right, but then if it gives you some code and it doesn't compile in or run under the framework you thought it was going to, that's not very good. But then again, it's a bit like my genetic programming for the fizzbuzz. Some of what it generates was rubbish. But at least the genetic programming example has some tests, so it could then filter whether it did what was required or not. Whereas ChatGPT just spews forth stuff. But that's okay as well, because if I Google something, Google spews forth stuff. And rather than just taking the first link and going, yes, I found it on the internet, it must be true, sometimes, top secret, sometimes people on the internet are wrong, sometimes. So sometimes you need to show the intelligence and think a little. And if a computer says, here's your answer, you can go, well, I don't know. Actually, it's the same with a book. If you read something in a book, it might not be right. Or it might have been right once. So you need to think. So you can use ChatGPT or search on the internet if you want. But you need to get brain engaged. And if something's magicked up some code for you or created a robot for you, it's the same with anything else. You need ways of testing whether it works or not, if it's fit for purpose. How to turn it off. That's pretty important with AI, right? And robots. And frequently, ChatGPT will spew forth code, And then you ask it afterwards, oh, how do I test this? Not everyone remembers to do that. And would you trust the tests it's generated? Just like AI's been around since the 1950s. It's changed. We wouldn't see a thermostat as being intelligent or making decisions now. And you probably don't think that my vacuum cleaner is particularly intelligent, or my husband's modelling guitars thinks or has a brain. But some of this stuff's useful. We need to engage our brains. Just as a wind-up now, AI obviously stands for artificial intelligence, but if you look back through the history of this, we see bits of it breaking off and getting names. So ChatGPT would fall under the name of a chatbot. What tends to happen with AI, and the same happens in philosophy, as soon as you get one small aspect of it working, it breaks off into its own discipline, gets its own name, like an expert system or a chatbot. And what's left is the murky stuff that we're not quite sure about. And all the way through this, people have been playing games as ways of getting the machines to learn stuff. And loads of first-person shooters and other such games use a bit of AI, and that's good fun too. Can AI replace programmers? Yes, but there's been an hour's worth of but there. Programmers use computers for lots of things already. If your computer's generating stuff for you, you need to be involved in it, you need to steer it a bit, and you need to engage your brain and think and see if it's useful. But do embrace some of the things like the fuzzers. Computers can do all kinds of useful things for us. Don't be afraid. Find out how it works a bit. Ask questions. So, will AI replace programmers? No, never. It hasn't happened since the 50s. Our jobs keep changing. And the same is true of all jobs. And a lot of that change is driven by changing computing. We're never going to be replaced. We're going to keep an eye on how things are changing. And some of it's cool, and some of the sci-fi stories, even if they're really dystopian, are great fun, if you're into that kind of thing. So just wanted to give you some space to think about this. There's papers published on how ChatGPT is working if you want to have a look. And that's me done. Any questions? Okay. A bit dazed.
No, we have a question at the back.
One at the back.
Marek.
Hi, Marek Kozalski from LINX. I should probably preface my question with Rainbow Alphabet Lefty Looney as, you know,
hello.
Position on this. Hi.
Yep.
You've obviously talked a lot about sci-fi, and one of the sort of recurring themes in sci-fi has been dystopia, but there's also been the utopia of AI will take away all of the boring jobs and leave humans to do the fun stuff. But right now we're seeing AI and like generative models doing the fun things like art and creativity, and is leaving us with all the boring stuff. This is not the AI that I was promised.
I know. I want a transporter and I want a replicator, but some 3D printers are going in some interesting places. And actually, like we've used machines to make music for a very long time, but it's the human in the loop thing, the feeding off each other a bit, that's the interesting thing. Just because AI can write some slightly formulaic pop music, I mean, that's fine if that's your sort of thing. I prefer my thrash metal, so like it, which also relies on computers. Yeah, it's doing some fun stuff. Some of it's not very interesting, some of it is interesting. And yeah, sci-fi is not all dystopian. Come on. Tea, Earl Grey hot, there, just like that. Why not? Were there some other questions?
Yeah, I was, one question I had is, so we have people who kind of program and write scripts and stuff today. What would your kind of, if you kind of had a, if they asked you a question, hey, I want to learn more about this, I'm a complete noob, where would you recommend that they start going to? Is there a starting point that you think would be helpful to them?
Absolutely. The bottom line is you're going to learn most by doing and feedback in the same way AI learns. So you want to try something and you need some feedback. And in some ways, the most valuable feedback you can get is by finding somebody else who can code and get them to talk it through with you. So, for example, I'm a member of a group called ACQ. They tend to focus on some of the curly bracket languages and also some Python and a few other bits and bobs. And some of the feedback I've got from just asking questions there is useful. So try stuff. If you find things on the internet, be slightly cynical. So Stack Overflow's got some great answers and some terrible answers. But try something. Start really small. Loads of programming languages, for example, if you want to do some scripting like Python, have got a list of tutorials. So start with the official website for the programming language you're doing. Try out some of the tutorials. Try out some basic bits. Find some existing code and tinker with it. Ask what happens if I change this or that. So iteration and feedback. But if you can get some feedbacks from some humans, you might learn quicker than if you just get stuff marked by a machine, if that helps.
Thank you.
Yeah. Question for Rashid.
I wonder if we're asking the right question here, because if I make the analogy with self-driving cars, I don't really believe in self-driving cars, but what is certainly happening is my car knows the speed limit. It brakes automatically. It stays in the lane. So I'm wondering about the tools that assist programmers as opposed to replacing them. In other words, will the AI debug your code for you? Will it test it for you? Will it document it for you? And assist you in writing better code? Maybe that's a more interesting question.
Yeah.
Will it actually replace the programming activity itself?
Yes, you're exactly right, which is why I touched on actually the automation side of things being useful, and you get automatic code formatting. You should see programmers argue about whether you put a pair of braces above each other, or one at the end of the line or not. You're like, why are you... And you can just run a script over it that goes, I'm doing it like that. And then the other person goes, and put them all back. And it can be the way they want on their laptop. And then you commit it to a central repo and it doesn't matter. So absolutely that. I wouldn't want the tests to be only written by the computer. I'd want to at least have some steer on what it was doing. For the fuzzers, it can find stuff that crashes things. But in terms of, if I wanted it to write a test for something simple like FizzBuzz, I'm in danger. You've got a bootstrap problem there going on. So maybe you start with some simple requirements or test yourself. And then maybe it can add some of them. And then you go, nah, hang on, now that I don't like it, that I've got to fill this order in twice on this form or something. So it needs to be a bit of give and take. I would not trust code that was only tested by a computer. I'd want humans to have been in the loop there at some point. But yeah, absolutely. Automate the boring stuff so we can have some fun. Or use our brain power to think more about some other things. You don't have to do all the mindless drudgery. And if you can automate some things, then why not? As long as you're sure it's working properly and you can say, hang on, I've changed my mind. That's the important bit. I don't want everything I touch to turn to gold. That wasn't what I actually meant. So, yeah.
Okay. Question from Malcolm over there.
Are you aware of any research into helping AI identify the difference between, the distinction between a fact and an opinion? Because humans seem to be quite bad at this and seem to be getting a lot worse quite rapidly. So reinforcement learning human feedback probably is not the answer. Is there anything better?
I can imagine that you could try and do that if you had a labeled data set. So for the reCAPTCHA, instead of traffic lights, it said, is this a fact or an opinion for everything? But then you'd have opinions about whether the opinions were opinions or facts. And I'm not sure what you could get with that. I say that's an interesting one, because I can't see how you could have a labeled data set that all humans would agree on, because that's what you said the problem was in the first place. Yeah, that's an interesting bootstrapping problem. I'll just talk about it over lunch. Can't help you there, mate. Sorry.
Do we have any more questions from the floor? We did have one that came in sort of earlier on.
Okay.
Maybe, perhaps you sort of answered it to some degree. So, could Skynet, Terminator, be a thing one day?
Skynet and Terminator theoretically could be possible, but that's why the human in the loop bit's really important, and that we can pull the plug if we need to. But yeah, bad things can come of any technology. A technology in and of itself is neither good nor bad. And it tends to be actually what humans use it for that steers things. So, yeah, could all be dystopian, but there could be some fun on the way, and maybe the world won't end like that. I don't know. Watch this space.
Yeah, quite interestingly, I had a piece of mail through my letterbox rather than a piece of electronic mail on Monday for John Connor, who was actually one of the characters actually on Monday. So. Yeah, maybe it was a message that because you were coming along this week. To...
What was the date on it?
Actually, I don't know about that. Actually, I didn't check.
Yes.
Yeah.
On that note of paranoia and despair, we're probably done.
Yes, I think we are. Yeah. So thank you very much, Francis. Thank you.